Okay, today we're going to talk about scatter plots and lines of best fit. And we're going to do this by hand, but the other handout that I gave you tells you exactly how to do it on a calculator. So you do have to have a TI-83, TI-84, one of those kind of graphing calculators in order to do it. First thing you'll have to do is to remember to go to your mode and turn your diagnostics on, and then you can enter this stuff just like it says on those notes that I'm including with your stuff. So you can find these lines of best fit also that way, but I'm going to show you how to do it by hand also. So these scatter plots that we're going to do just are a great way to show trends in your data or whatever information that you might be collecting. And so when you talk about this line of best fit, it's like just approximately what's this in general, what's this data doing? Is it increasing, decreasing, whatever? You just want to see if there's a pattern going on. So this is very helpful. What we're going to do first is just label our graph over here, our coordinate grid, and then we're going to go graph all these points. So let's just label these 1, 2, 3, 4, 5, 6, 7, 8, 9, and these are our games. And then these are going to be our yards over here. And my data just goes from, looks like 225 up to 350. So let me just start here at 200, 225. I'll do 50 increments, 250, 275, 300, 325, 350, 375, 400. Okay, so just looking at our data for game 1, we went 348 yards, so that should be somewhere around here. For game 2, we went 350 yards. Game 3, we did 300 yards. Game 4, we did 295 yards. Game 5, we did 280. 6, 250. 7, 225. Okay, so do we see a pattern here? What's going on? What is our pattern? What could we come to some kind of conclusion? The more games we play, what happened to our yardage? Well, we could say the more games then the less yardage we gained. Okay, so, and that's just a prediction. So then you could say, well, in game 8 or game 9, we might, even do less than 225. We might be around, 200. So that's what you could expect out of that. So then it tells us to draw a line of best fit here on the data. Well, and you're just going to sort of estimate these. Now, when you do put them in your computer, then in your calculator, you'll actually, get an equation for that. But let's just say, just in general, maybe somewhere right around here would be our line of best fit. Why that's not, let's see if I can draw a straight line here. Something like that. It's supposed to be a straight line. And then you could see what's the equation of that line, and then sort of just in general be able to tell, okay, well, if we play 12 games, what would be expected once I come up with that equation. All right, so notice then your data plot can have a positive or negative or no correlation at all. So in this case, the very first case here, when we talk about what's happening, is it positive, is it negative, or there's no correlation, remember that's always talking about the end behavior. What's happening at the end of this line, which is the right hand side of it. Well, notice this one's going up. You know, the trend is this way, so that's a positive correlation between this information. This one is going down, so it has a negative. And this one's just all over the place, so we can't say, you know, there's any correlation whatsoever to whatever it is that we're graphing here. So what type of correlation did the data have in the example, the very first example? Well, we could say that's probably a negative correlation. All right, so here's our second example. Old Geyser is a geyser in Yellowstone National Park for more than 100 years. Old Faithful has erupted every day at intervals of less than 2 hours. The data in the table may suggest that the time between the eruptions may be related to the length of the previous eruption. Do a scatter plot. Okay, so we still have to do these. So here's 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, 5, and then 5.5. So my data over here goes from what? 57 to 92. So let's do maybe 5 increments. I don't know. So yeah, if we did like 55, 60, 65, 70, 75, 80, 85, 90, 95. And just remember, you have to always have that same increment on each one, as long as the increments are the same on X and then your increments are the same on Y. Just don't mix them up. Okay, so we're going to go graph these. So 2 is at 57. 2.5 was at 62. 3.0 is at 68. 3.5 is at 75. All right, so we're seeing a little bit of a trend here. 4 is at 83. 4.5 is at 89. And then 5.0 is at 92. So looking at that, what kind of correlation would you say this has? Positive, negative, or no correlation at all? Well, yeah, it's going to have positive, right? It's going up each time, so positive correlation. So what's the independent variable? And we didn't label these, but this should be length, and this is our time till the next eruption. So our independent variable is the length of the eruption, and then time. So let's name 2 points on the line, and we can just get that from our table. So we have 2 and 57, and then let's just use 3 and 68 so we don't have decimals. Okay. Find the slope of the line. Well, given 2 points, we know we can find the slope with our formula. M is equal to y2 minus y1 over x2 minus x1. And so we're going to find our slope. So it's 68 minus 57 over 3 minus 2. So 68 minus 57 is 11 over 3 minus 2 is 1. So our slope is 11. So then we know we could use one of those points and then write the equation of the line. So if m is equal to 11 and we have a point on the line that's at 257, we can use the formula y minus y1 is equal to m times x minus x1 formula to solve for that equation. So y minus 57 is equal to our slope, which is 11 times x minus 2. Okay, so we do our math. Y minus 57 is equal to 11x minus 22. Then we're going to add that 57 over to the other side. So let me bring it over here. So y minus 57 is equal to 11x minus 22. Add the 57 to both sides. That gives us y is equal to 11x, and that is 35. And like I said, the notes that the handout that I'm giving you with this shows you also how to come up with that on the calculator. So what would be the best prediction of the time until the next eruption if the length of the eruption is 2.3 minutes? Well, remember 2.3 minutes, that's our x value. So we're going to stick that in for x and see what would be the time. So y would be 25.3 plus 35. So y would be 60.3 or 60.3, what is that, minutes, I guess? Yes, in minutes. So 60.3 minutes until the next eruption. So what would be the best prediction of the length of the eruption if the time until the next eruption is 70 minutes? Well, this 70 minutes, remember, that's our y variable. So we're going to say, here's our equation, y is equal to 11x plus 35. Well, that's our y, so 70 is now 11x plus 35. And we will solve for the x in this, the way this one's asked. So 35 is equal to 11x. And would be about approximately 3.18 length until the next eruption would be the length of the eruption. So watch how those are worded. Make sure that you know which variable they're asking the question for, whether you're looking for the x value or the y value or whichever one that they're giving you. And yeah, use your calculator on that if you want to, and that's fine. Thanks.